The table gives values for a function f at selected values of m. Which of the following graphs could represent these data in a semi-log plot where the vertical axes are logarithmically scaled? That's a terrible word. All right, a semi-log plot basically takes a coordinate plane and makes it look different so that when you graph something that's logarithmic, you end up with a straight line. Okay, semi-log plots, basically what it looks like is the vertical part of it is you'll have a straight line, and then it gets smaller, and then it gets smaller, and then it's like really small like that. You guys are just regular old graphs. So let's get rid of you, and let's get rid of you. If you look closely and squint your eyes, you could see this process where you have all this space and then it gets closer and stuff like that. And the same thing happens for this one right here for D as well. Here's the situation though. The goal and the purpose of a semi-log plot is for you to demonstrate a logarithmic equation as a linear equation. So if I look at where these points are, C follows these points, okay? So like here would be 1, and then like, that would be, I guess that if that's 10, then that would be my 18, and then 2 would be my 30, and 3 would be my 58, which happens up here. And my dots are represented in a straight line. Looking at these numbers, you know that these numbers are not linear. This guy gives you something that's curved. Again, one last time, the goal of a semi-log plot is to represent logarithmic data as something that looks linear, and C is the guy that does that.